We're going to discuss how Lafayette's Storm Road program, developed by Lafayette Consolidated Government, which is the main governing body for Lafayette City Parish, which is the county equivalent for most of the United States, and how we're working with the Acadiana NPO to take the data from their emergency response system to use it for our arterial roadway network to program projects and make improvements on our roadways to ensure resiliency during major weather events. So just to give some background on our community and our part of the world, Lafayette is considered by many metrics to be, the 4th or 5th rainiest community in the United States. On an annual basis, we do get about 62 inches of rain, which is about double the national average for rainfall in the United States. Our high water mark was in August of 2016 when we received over 20 inches of rain in a 24-hour period, and obviously experienced many issues with that and with basically the complete shutdown of our roadway network system.
So as Ashley mentioned, we have a lot of issues with rain and flooding. We actually had a pretty good response to it. We had dozens of workers, trucks, chainsaws, ready to go for hurricanes and flood events. But where we hit the problem was we had no real way to manage them. A lot of this was being done by dispatchers who got a call and would use pen and paper to track these different requests, maybe even sometimes sticky notes and such. So we never really knew where our workers were, which requests were taken care of, which ones are being duplicated. And we had a Hurricane Delta came through and we had thousands of requests. So trying to think about managing those without a system like we developed is just a nightmare. We also had no long-term data for storm events, and when our workers went out there, we didn't keep track of where we had been. So that was kind of the issue and why we developed what we did.
So as part of our long-term planning process for the Metropolitan Planning Organization and in developing our public participation plan, we did a lot of research on new communication methods, because when I started in 2005, we did everything, what we consider old school now, just traditional public hearings, traditional paper surveys, paper comments, that sort of thing. And working with that, we really found there's been this huge shift societally towards digital interaction. Most people nowadays, a lot of people say even text me or email me before you call me. And higher generations, this is a trend that is even more pronounced. And so we surveyed, through the development of our plan, we surveyed our government entities and we asked them, how are you collecting data on roadway flooding? And Lafayette was the only system that had kind of, within the past year, had developed a digital reporting system, but we still were missing those other communication methods. And we still were seeing the limitations of only dealing with phone reporting. But our other jurisdictions are only still using phone reporting and paper documentation. So they really had no data to provide to us with regards to flooded roadways. So while in the midst of we were working on these issues, we had Hurricane Ida happen, and Hurricane Ida affected the parish where my family lives, and Hunter's family has a lot of family that live in that parish, St. Charles Parish, St. John Parish. And there we noticed while we're monitoring it, there was huge amounts of people interacting and reporting things via social media. And I was monitoring it because my dad and my brother had stayed in St. Charles Parish, and they had had a tree fall in their neighbor's house. And they were, trying to plan to see how they could get out. And people were actually posting on Twitter, on Facebook, where roads were flooded at. So I knew which roads were flooding and which intersections were flooding, so I could help them in case they needed to leave if they had some sort of major event like that. And so through the research, we were working with communication tools. We really found a lot of good data to support Twitter as probably the best social media or the easiest social media to integrate, because it is used for a lot of breaking news. It's more news focused. It's very similar to the communication tools when you're working with a cell phone. So, and a lot of the research from the Pew Research Center supports that. So we were excited to see that, and we were excited to integrate it into the disaster reporting system. And so, as kind of more trends that we were seeing, this is the sheriff for St. Charles Parish. he's asking people to not report things via social media. And I think it's just because these younger generation is just so used to this form of communication. And we're really missing it. We're really trying to work with our local governments to see how we can capture this information and integrate this, because this is the way the world is going. We need to figure out how to get away, or at least integrate our older school methods with our newer school methods.
So what we developed was an online platform that essentially is a Google map where our dispatchers could put requests. Those requests then went to our workers in the field. So we gave iPads out to our workers in the field, one for each crew, and they were able to look at this map, which we'll show in a little while, and actually tell us, okay, we're here, we're working, we've completed this one. And so we could more easily keep track of the requests as they come in, where they're at exactly. And we didn't want to duplicate requests as well. We also we recently put in a Twitter component so that people could reach out on Twitter. They could tag, right now it's hashtag Storm Mode Lafayette, and it'll show up to our dispatchers. So they could put these requests into the system from there. And everything in this is archived. We're keeping it for historical purposes. We want to use that data to plan out our roadway resiliency. Here's just a screen that kind of shows a screenshot of the actual program. On the left, you see the mobile view. And each little, it's kind of hard to see, but each little blockage or tree or any icon you can see on that map represents a different type of request, of issue that's been reported to us. And if they change color, that's them saying if it's yellow, they're working. If it's green, it's been completed. On the right side, you'll see a desktop view. This is where our dispatchers will sit on this screen, and they can put in a new request while at the same time looking at the requests that already exist in order to make sure we're not duplicating stuff. This is just a technical page. Most of you probably look at this page and see gibberish, but a programmer will look at this page and say this is pretty basic. A lamp stack we provisioned an Amazon web server and then put a lamp stack on it. And LAMP is an acronym that stands for Linux, Apache, MySQL database, PHP. And what this is basically Linux is an operating system. It's like Windows, but different. And then Apache is a web server, which helps us actually host the website. MySQL is a database that stores all the data, and PHP is the coding language we used. This is a pretty typical stack that's been used for a long time now. It's actually a fairly basic program. And this is an up-close shot of the My Jobs tab we have. This is where a worker could come, look at all the different things he's been assigned, and you could see that this particular issue we clicked on is trees and limbs. It's assigned to Hunter Fontenot. Its status is completed. So we have a few more details in here. We can update the status of it, whether it's working or not. And this page actually is customized based on the person who logged in. So I can see a lot of them because I'm in a management position, but a worker out in the field will just see what they've been assigned. This next page is the new request tab. It's a tab that our dispatchers sit on. And when a request comes in, we log a certain amount of information just to be able to get out there and talk to whoever requested it. And we can also zoom in and see like if a request has already been made at this location. We don't want to duplicate it. So yeah. And this is the Twitter. This is a small page on the Twitter API. So the Twitter component, Twitter actually puts out an API that you can grab data. You can search by hashtags. And then I put a little link there to the component we use to connect that with PHP. So this is how we're using Twitter inside this program. So this is a screenshot of the actual Twitter request page. If you'll look on the left kind of the bottom left corner, you'll see the Twitter request tab has been selected. It's highlighted blue because there's a new tweet. The tweet in the middle has a highlight of blue around it as well to show that it's new. As you can see, each of these tweets has either storm mode testing or storm mode Lafayette in a hashtag. And we gave 3 basic options, which we'll go over in a video in a second. But the 3 major options are to make a request, to put it in as a legitimate request, to acknowledge the tweet, to say it'll actually send a tweet back to the original tweet saying a very generic, thank you for submitting a request, we appreciate it. And then the last option is to hide tweet. If there's any extraneous, malicious tweets or anything like that, we want to be able to hide them so that we can really get to the meat of any of the problems. So now we have a video, I believe.
Yeah,
there we go. So it's showing that, any hashtag storm mode testing or hashtag storm mode Lafayette will show up in the system. And I believe they go through the buttons actually backwards in this video. So we'll start with the hide tweet is being shown. So a tweet comes in at the bottom there. And let's say this one's extraneous, we hide it, it disappears. This next one, we acknowledge it, it'll send something back to them. And then they show the make a request will pop up with a similar thing to that new request tab to put in the same information. And it actually grabs information from that tweet and puts it into that request automatically. So some other social media considerations we had, naturally, Facebook was a big one because it's the biggest social media platform. However, in 2016, they actually shut down their API. Now that may just be to general users. We're hoping to reach out to them as a government entity and talk to them and say, hey, this is for safety purposes. Could we please access this? Because it does exist, it's just not available. And then Waze was another platform that naturally fit with this. Since we have data to share with them, they would share data with us. It's kind of how they work. And so we are actively pursuing ways to just better this program all the way around.
So from the planning side of it, the really exciting aspect of this is having all this information on flooded roadway requests and for our resiliency of our transportation network. So it's really helpful, and you can see, and this is what we get the archive, what it looks like. All the points represent a request that was managed and deemed verified by Lafayette Consolidated Government. It gives the name and date of the event, which obviously is helpful for meteorological purposes because we know, how much rain fell on a certain day. And it even provides the timestamp of when the request was submitted. So we have that as well, because then we know by time how much rain had fallen by that point. It provides the address, again, a pivotal information for analyzing street flooding issues. And it provides, in this case, this is a street flooding related report. But they also, like you mentioned, trees down, things like that's really important. Trees falling down is obviously a very dangerous situation on our roadway network. It definitely can impede operations of our arterial network system. So this is the data that we get, and it's really exciting for us to analyze. And this is just an example of a heat map of the data requests related to street flooding. But it's very important for us in Louisiana to have this data because we do get a lot of requests through our programs for raising roads, based on flooding issues. And we really need to have that data for that because a lot of people will say, hey, we feel like this road needs to be raised, X amount of feet. And we need to have the data to support that because this is all very data driven. A lot of times we don't really have anything other than more anecdotal data for doing this programming. But again, it's important for us because in Louisiana, because we do have issues with regards to flooded roadways impeding emergency response for crashes or even things like heart attacks and such, where a minute makes a big difference. And then we do have, unfortunately, some motor vehicle crashes related to inundation of the roadway where people have drowned in their motor vehicle. So we need to make sure that we're not getting that level of street inundation on our major arterials. Again, application purposes, the PROTECT program, obviously big program for metropolitan planning organizations and state DOTs that is directly related to roadway resiliency. And we programmatic as well as competitive. And we will be using obviously this data for analyzing and developing projects. Integration to our preservation projects. So the picture you see right there, that is of a roadway project that's through our what we call our pavement preservation program with the Metropolitan Planning Organization. For our overlay program, we do frequently do drainage improvements integrated into our pavement preservation projects to ensure the resiliency of the roadway. In this particular case, unfortunately, this roadway was already under construction when they discovered this issue with this particular head wall that needed to be replaced because it's about to collapse, possibly during a high weather event, which obviously would be a major issue for this particular community because it is a major arterial for them. So we're looking, this data is really pivotal for us to be able to make these improvements on the front end of projects. Because right now we're working with a lot of anecdotal data and then just going out, unfortunately, just going out in the roadway when we're having a heavy rain event to see before we start the preservation process on the roadway. And then long-term planning, resiliency in Louisiana is a major factor, planning factor for us. We need it for, obviously the reasons mentioned, but it is a big part of when we're doing our long-term project selection and integration, we need to have this data. So this is our contact information. And I know we're taking Q&A at the end, but thank y'all for letting us have on and talk about our projects, and we'll be happy to take any questions or any contacts that somebody would like to make.